And go. So I'm here in Santiago on a beautiful late December day approaching Christmas. Believe it or not, lots of people running around in shorts, and I had the privilege of being at ESO headquarters in Chile with Luis Chavarria Garrido, who is the ESO representative in Chile. And I don't know how long it's been since the ESO representative in Chile has actually been from Chile, but Luis, you're from Chile, correct?
Exactly, I'm from Chile.
And we've been discussing, this has been a hallmark week for the ELT in northern Chile, which is under construction as we speak. You've received, actually the first mirrors have been shipped from Europe and they're underway. They're in the middle of the Atlantic, and they will come into port at Antofagasta. When, Luis?
We think, well, I don't know if people knows what the ELT is, but just to
The European,
know,
the
extremely large telescope.
extremely large telescope, a 39-meter optical telescope that's been in the planning phases since when? It's been, what 2000?
Many years. Many years it's under construction. More than half of it is already done. And as you said, this is a very important moment because the first batch of mirrors for the big mirror are on their way, starting from France, and they will be here in 1 to 2 months. So it's still going to be, we're going to have a nice weather. It's going to be summer, and we're getting ready to receive those mirrors at the port in Antofagasta. Then they're going to be transported to our observatory in Paranal, and we're to start doing the first coatings. Okay, we're going to cover the mirrors with a reflecting layer and get them ready for a few years to do the first observations.
And how many were in this first shipment, the mirrors?
18 mirrors.
18 mirrors, but we have a total of 798, and each of those mirrors is about what, 1 meter in size?
Yeah, approximately 1.5 meters.
1.5 meters in size.
Those have the shape of hexagons, so they're kind of similar. People have in their minds the James Webb telescope, so they're kind of similar to James Webb. And we're going to have many, and also we're going to have more than 100 spare mirrors. So we are going to be receiving mirrors for a while now.
100 spare mirrors. That's incredible. But the resolution, the detail that this telescope will get us, you told me in the interview just now, would be something like 10 times the resolution that the JWST, the James Webb telescope gets. And we were just talking about the Horsehead Nebula, which is a famous nebula that we've seen all over the internet, and JWST is an incredible image. But what you're saying is that the resolution, the detail that the ELT will offer once you're underway is going to be 10 times that, something like that?
Yeah, we're going to see more details of the horse there. But one important thing is that there's people may be thinking, why do we build bigger and bigger telescopes? And you just gave the answer. The bigger the telescope, the higher the resolution, more details we can have in the final images. And of course, the ELT is going to be bigger in diameter than the James Webb, and because of that, it's going to have a higher resolution. Now, we try to do not make a competition here because those amazing telescopes, the James Webb and the ELT, are complementary. Okay, they are observing things that can help each other to answer the scientific questions that the astronomers have. So we're very happy to be in this stage in the construction of the ELT, hoping to have the first light at the end of 2028, and very excited, to have this huge machine working and trying to answer the great questions that we have in astronomy right now.
So one last thing, we were talking about what's next after the ELT. At one point, ESO proposed a 100-meter telescope, but you said that's not really possible in the present form. And why is that, you think, 100 meter?
If we build a 100-meter telescope, the immense size of, for example, the dome of the telescope. If you imagine right now the ELT the dome of the ELT is a building which has 80 meters in diameter and 80 meters of altitude. So if we want to build at a 100-meter telescope, the building is going to be much, much bigger, and it becomes almost impossible to be able to manage or to move such a huge structure. So probably a 100-meter telescope is not the way that we're going to move forward. Maybe we're going to try to do something that we call interferometry, to combine different telescopes. I think that that is probably what we're going to do in the next few decades. But we're very excited first of knowing what can we do with the current big telescopes, and from that we're going to get answers to the current questions in astronomy. But whenever we get an answer, we get 3 more questions, and those are the questions that are going to motivate what is the next huge infrastructure that we will need to answer the next generation questions in astronomy.
Is it possible, I didn't ask you this in the interview, but is it possible that the materials will become so advanced, the material structures, science, the composition will become so advanced that we could in the future build a 100-meter telescope because the structure of the materials that would hold it, the dome, support the dome, would be strong enough and lighter, much lighter but stronger? Have you thought about that?
I think that that could be a possibility, but for my personal taste, I still think that it is a greater avenue to try to put our efforts in having interferometry working better.
Interferometry is right.
Because if you make it work at bigger distances, you can emulate not a 100-meter telescope, but a 200 or 300. Okay, so it gives you more possibilities than putting all the effort in building just one big telescope. Okay, with interferometry, you could do things, and I'm going to get a little bit crazy here with ideas, but you could do, I don't know, interferometry in space. I don't know, you could do interferometry with telescopes in the Earth and telescopes in the Moon. I'm probably going to be dead if that happens at some point in 100 years more. But that's my show, what I'm choosing, okay, for the next steps.
So again, we've been at the European Southern Observatory headquarters in Chile. It's not the administrative headquarters, that's in Garching, Germany, but this is the Chilean headquarters from where ESO oversees all its operations of the telescopes within Chile. Thank you, Luis, so much for taking the time today. Great job.